Let's go now to the second piece of the function, which is the quadratic. So if you have a device at home and you know how to use the Desmos, or if you have a graphing calculator that can generate the table of values, that would be great. But today we're gonna go to the old school way. That is the substitution method. So we have the values of x from -3 to +3, which is I determined, it's a predetermined values of x. So as you well know, it's easier if we use a positive sign, positive numbers first. So this will be f of 3 equals, notice that there's a negative before the x, so we're gonna put the negative and then a parentheses 3 to the second power plus 4. Now you're gonna start based on order of operation. 3 to the second power is 9. Again, there's a negative outside the parentheses. That's the only time you're gonna put it or write it before 9, plus 4, and then -9 plus 4 is -5 right here. So if x is 3, the f of x is -5. What if x is 2? So again, it's an old school. Let's change this. X is +2, +2. F of 2 is equal to negative of +2 squared plus 4. So 2 squared is 4. There's a negative plus 4. -4 plus 4 is 0. So if x is 2, f of x is 0. Now, I'm going to continue this later on, but let's go to the -3 first, so that you would know how to manipulate or substitute using a negative value. Let's erase this. So what if my x is -3? So just simply substitute -3 there, -3 inside the parentheses. Take note, again, we need to keep the negative outside the parentheses. Now, -3 to the second power, or -3 times -3, is still +9. Again, there's a negative in front. Put the negative there, plus 4, and you're gonna get -5. So if x is -3, the value of f of x, or the f of x, is -5. After completing the table, now we're ready to graph the coordinates. It's up to you where you want to start, but I suggest you start from the positive side. So +3, -5. So +3 on x. So I'm going to move 3 to the right, 1, 2, 3, and then -5 down, 1, 2, 3, 4, 5. Again, I strongly suggest that you use open circle for now. So we're done with this first coordinate. The second coordinate is 2, 0. It's right here. 1, 3, 1, and then you move up 1, 2, 3. Again, open circle right there. 0, 4, right here. -1, 3, there. Then -2, 0, right there. And then -3, -5. This is the last coordinate. Now, if you notice, imagine if you trace these points, you're going to create an upside down parabola. Now, you need to go back. We need to go back to the given function, and it's particularly or specifically on the domain restriction, which is x is greater than or equal to 2. Now, we need to grab this greater than or equal to symbol from our key concept, and it says we need to use closed circle and keep the right part of the graph. But from where? From +2. So if you look at the graph, +2 is right here. So this is 0, 1, 2. +2, we need to keep the right side of the graph. Now let's try to trace the parabola. I'm gonna use a pencil for now. So the parabola kind of like this. It looks like this, right? But again, from based on the domain restriction, x is greater than or equal to 2. This is x is 2. When you say greater than, you need to keep the right part of the graph, which is only this piece. So you need to erase all of these and keep this part only. So I'm going to keep that from this open circle all the way down there. That's the graph. Now, what do we do with this open circle? Based on the restriction, it's greater than or equal to. Every time you have an equal to symbol there, it's a closed circle. I'm gonna put a I'm gonna shade it in, and that is the second part of the graph, and that is your equation 2. So what do you do with the rest? You need to erase this part. How about this open circle? Just ignore them. If you have an eraser, then just erase those parts. Now to recap, so this shows the graph of the two pieces. The first chart here is the graph of the linear function. That is the graph of the linear function, and this chart is the graph of the parabola or the quadratic function. Now, this one is the combination. This is what you want to show as your complete work, and that is the graph of the entire piecewise function. Thank you very much. Please subscribe.